Hello world and welcome. Today we'll talk about CNNs. My name is Harris and let's get started. So for more tutorials, hit the subscribe button or leave a like or comment there. I'll be really happy about it. What are the pros of CNNs? You can apply it basically on unstructured data such as image classification, speech recognition, natural language processing, etc. It will learn the filter automatically without mentioning it explicitly. You can apply it within feature learning here, and the spatial features refer to the arrangement of pixels and the relationship between in an image to just take the features itself. If you imagine it here, you have on the left side two examples, two image types. We'll start with the 2D area here, where we have a picture of black and white, for example, animal or something like this. And you can also have here the 3D area, where you have also the three color channels like red, green, and blue. And you can also, let's say, start a classification here. Basically, there are four steps of this CNN network here. We are applying first of all a convolutional layer, afterwards the MaxPooling, flattening everything because we don't want to have multiple dimension here at the output, so we flatten everything and then full connection to the ANN. So if you consider the CNN layers here, you have on the left side input. This is just a matrix, 28 times 28. And you have a black and white picture here, just handwritten digits. And then you can see here a lot of feature maps. These are these blue squares. We apply first of all convolution layer, then a MaxPooling. Afterwards, you can have another convolution layer, then MaxPooling. You flatten everything here to give it to the next, or to pass it to the next ANN here, for the fully connected neural network. The CNN filter here, which we are applying, you have some image, you have some filter or feature core detector, and then you have the output, so the feature map itself. And this CNN layer, which we will start first of all, we have here an input image, then we apply some filters. The filters you can imagine like some feature detectors. If you imagine a face, then the features can be like a nose, like a mouth, like an eye or eyebrow or something like this. So you have a lot of filters, you apply them, and then the output is the convolution layer, and here a lot of feature maps itself. So each feature map has its own, let's say, filter. If you check, or if you consider how the basic convolution operation looks like, then you have here on the left side input here. You apply it with a feature detector or filter. This, in this case, it is a vertical filter. Then the result of feature map is a 2. If you sum up all this multiplication here, it's a 2. So if you go further from the left to the right, you have this again, this 3 times 3 matrix is considering here. And you apply again a filter, and then you have a 6 as the output, so it's a sum of all these operations here at the feature map. The edge detection itself, you can imagine like the picture here of these white houses, the crosswalk, the street, etc. If you apply here two types of filters, let's say the vertical edge detection and the horizontal edge detection, at the very top you can see the houses itself, so you can see more the shapes of the houses. Down you can see more the crosswalk, the street, the horizon, etc. So this is actually the edge detection. If you apply the vertical edge detection here in an example, you have an input multiplied by the filter, by the vertical filter here, and then you have output of -13 here. The horizontal detection looks like this, that you have here in the middle the 3 times 3 matrix. If you apply it here on the input, you have again horizontal detection of the feature map. There are many filter types. The most important are here on the left side, the Sobel filter and the Chow filter, which you also have in our next tutorials, where we will predict if input image is a dog or a cat, for instance, or the handwritten digits, for example. After we have everything, we have input image here. We applied the convolution, or then we have the convolution layers with the feature maps. Afterwards, we have the pooling layer here. So what is the pooling layer or the MaxPooling actually doing? We want to downsample the picture or decrease the resolution itself of the picture. That's why we only take the max value of the input matrix here on the left, as you can see here, the red and green, etc. Colors you can see at the first time, the red square. There's the max value is 6 and then 8, etc. So that's kind of a downsampling approach. So after we done this pooling layers, we decrease the resolution. We only have the most important information of a picture. Then we are flattening everything. We're flattening it because we want to have a vector here. So we are going from left to right through the pooled feature map step by step or sequentially to have a vector here. And we are taking this as the input for n. So this is the fully connection where we are taking the flattened vector here as the input. We have a fully connected layer, so this is a little bit different. Instead of the ANNs, we have really here fully connected layers in between. Then we have output value here, which are 2, because we want to predict whether it's a dog or a cat, so classification approach. So here we have on the left side the input, it's a dog, so our output will predict 95% it's a dog. You can see here the probabilities within the neurons, and this is what you have as a result. The softmax, which come at the end, after ANN we are applying the softmax. It's basically there because we want to have a nice normalized probability, as we saw here. As we see the picture here of an airplane, we want to have normalized probability at the end of the day within 93%. That's why we applied the softmax. Optimization approach, which you can do here by adding some dropouts in between. If you can see on the left, you can have the standard neural net. If you, after applying the dropouts, you can have a more generalized neural network. If you consider to maybe in the future take this neural net for other animal types, let's say. So thanks for watching. For more tutorials, please hit the subscribe button or leave a like, comment there. Thanks a lot and see you soon.